Okay, this is PO4 mathematics. PO mathematics 4. We are going to learn about the coordinate geometry in XY plane. Okay, coordinate geometry in XY plane. So initially, Pute, we need to learn about the equations called parametric equations. Parametric equations. What do you mean by this parametric equations means, Pute? You can say if you get an equation just like this, you get y equals to x squared plus 4x minus 1. This is called a Cartesian equation. We already learned from our small grade the Cartesian equation, and we plot them on the Cartesian plane. We used to plot them. So that is what you learn about the Cartesian equation. This parametric equation means, Pate, a Cartesian equation has two main variables, no? Two or whatever the main number of variables. These main variables are explained by another variable, another parameter, another term called parameter. It's called the parametric equation. So you can write parametric equations are the equations which explains the main variables by the term called parameters. Parameters, right? Okay. So mainly the focus on this parametric equation, because sometimes like when you're building a main equation, sometimes it might be adjoining with another terms, another parameters may be affecting for that main variable. For example, if you want to get the demand curve and the supply curve. So when you're drawing demand and the supply and the demand and the price, demand of a product and the price. If you plot it, price. So sometimes for the straightforward, we kind of find a relationship between this. But you can say demand is depends on the some kind of a supply. Suppose that it's kind of a function. Demand is depends on the supply, and price also can be depends on the supply of a product. So straightforward, we don't have a relationship, but we have another third variable, which is where you can explain the demand and the price. According to that only, we plot the demand and the price curve. That is just a simple example for that. So for such situation, we can use this third variable called the parameter, which effect for this effect, right? Okay. Let's go ahead without discussing much things. We don't want the much of a practical aspects for at this level. We just learn the how to form a parametric and the Cartesian equation based on that. So initially, let's try to learn about how to form this parametric equation. Right. This is one example they used to give us. Example 1. They used to give us x is equals to t squared plus 1. And y variable they have given, it's t plus 2. Right. They have given the variation of the t to t. They used to give us t is varying from minus 3 to plus 3. The first point we should know is plot the graph of y against x. That's the first question we should know how to do using these parametric equations. This is what you need to do. Initially get these x values. X values varying from, sorry, not x values, actually the t values varying from parameter. First we have to get the varying the parameter t varying from minus 3, minus 2, minus 1, 0, 1, 2, 3. Basically, we can plot the basics of it, but sometimes there may be, we need to draw the decimals as well. But for the moment, we can draw in with the integers is enough. Now see whether if this, with this given t values, what is the variation of x separately and what is the variation of y separately. So if you get them, if x is minus 3, minus 3 square is 9, 9 plus 1 is 10. If x is 2, it's 5, it's 2, it's 0, it's 1, 2, 5 and 10. Then put the y values. Minus 3 plus 2 is minus 1. Minus 2 plus 2 is 0. 1, 2, 3, 4 and 5, right? Now you know that these coordinates, but now you can plot these coordinates. What is that? 10 minus 1 is a 1 coordinate. 5, 0 is another coordinate. 2, 1 is another coordinate. 1, 2 is another coordinate. 2, 3 is another coordinate. 5, 4 is another coordinate and 10, 5 is another coordinate. So with that you can plot these graphs, right? Then x values vary from 10 to 1 and y coordinate vary from minus 1 to 5, right? Okay, we will plot this. I think drawing up to 10 is enough. I just draw a little bit of extension. Right, okay, but this is x values, right? We'll try to plot the first coordinate. But the first coordinate 10 minus 1. 10 minus 1, it's here. Yeah, I'll use a different color, then it will be much prominent for you. 10 minus 1, it's here. The next one is 5, 0. Then 2, 1. Then 1, 2. Then 2, 3. Then 5, 4. Then 10, 5. Now you can see it's a graph somewhere like this. So this is the Cartesian graph, which based on this given parametric equation. So initially we should know how to do this, right? Okay. The next question they can ask from this kind of a question is form the Cartesian equation. Form the Cartesian equation. Part B, they can ask you, this is part A actually. This is part A. Part B, they can refer is find the Cartesian equation, which explains by given parametric equation. With parametric equation. So if you come up with the first parametric equation is x equals to t squared plus 1, x equals to t squared plus 1. Second one is y equals to, we'll get this t plus 2. Yeah, t plus 2, right? Equation in form of y equals to fx. You need to find the equation of y in terms of x. So what you need to do, y should be subjected. So what you can do is you can subject t from one variable and substitute into the other. That's the usual technique we do. Since they ask you to subject y in this equation over here, I will subject t from the first equation. I will label this one as my first equation and this one as my second equation. From 1, subject t. So you can write x equals to t squared plus 1. So first you can take 1 to other side. T squared equals to x minus 1. Therefore, t is equals to square root of x minus 1. Then what you can do is substitute it in 2. Substitute in 2. So you can write y equals to square root of t minus 1 plus 2 is the equation which is explained by this parametric equation. That is the way of understanding this kind of a question. So this is the entire question at once. You can see it. You can see it at once, right? Okay, that's the way of doing this. Right. Let's go ahead with another equation as well. Right. Let's go ahead with another one. See, example 2. I will get a little bit of a contradictory question. X equals to t over t plus 1 and y equals to 2t over t minus 1. T varying from 2 to 6. 2 to 6. After first part of the question, they can ask you, draw the Cartesian equation. Cartesian equation. Part B, find the Cartesian equation. Draw the Cartesian equation, draw the graph which is explained by the Cartesian equation anyway. Find the Cartesian equation is the second question. Initially, we will get the part A answer. Let's see how to do it. The t is varying from 2 to 6. So I just mark 2, 3, 4, 5, and 6. Then we can mark up the x values. But if I put 2 here, 2 over 3. It's 2 over 3. If I put 3, 3 over 4. That is 4 over 5. This is 5 over 6. 6 over 7. Right? These are the x coordinates for it. Then if you draw the y coordinates, what you can say here is if I put 2 to 4, 4 over 1. It's 4. If I put 3, 6 over 2. It's 3. If I put 4, 8 over 3. If I put 5, 10 over 4, it's 2.5. Sorry, 10 over 4, 10 over 4. Ne? If I put 5, 10 over 4. If I put 6, 12 over 5. So the coordinates are 2 over 3, 4, 3 over 4, 3, 4 over 5, 8 over 3, it's 12 over 5, right? Let's try to draw this graph with the panoramic. X coordinates, yes. We'll just mark like this. The y coordinates are up to 4. 1, 2, sorry. We need to make it a little bit smaller. 1, 2, 3, 4. So y values. X values you can mark 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1. That is enough. Ne? Actually, yeah, 1. This is x and this is 1, 2, 3, and 4. The first coordinate is, I will just get one as 0.2, 0.4, 0.6, 0.8, and 1.0. So if you refer the first coordinate, put 2 over 3, 0.67, 0.67 somewhere here, and 4, 0.67, 4. This is the first coordinate. Then other one is 4 over 3, 0.75. 0.753. 53. Then next one is 4 over 5 is 0.8. 8 over 3, put 8 over 3 is 2.66. This is 0 0.812, 0.2.66. Somewhere here. Yeah, then 5 over 6. 5 over 6 means 0.833. 0.833, well, it's 10 over 4. 10 over 4 means 1.25. 1.25 and 6 over 7. 6 over 7 is 0.85. Again, it has slightly increased. 85, it's here, and 12 over 5. 12 over 5 means it's turned up to 2.4. Point here. So you can see it's a graph somewhere like this. Turns and goes like this kind of a graph you can see with that. So that's a basic shape of it. Now, yeah, that's a basic shape of it. You can just sketch out the plots over here. Then part B is you need to make them into a one Cartesian equation. So you can say x equals to t over t plus 1. It's better to subject subject y in this equation. That is the usual format of writing a Cartesian equation. Right? So then I will just go ahead with this. So you can say this, you can mark this equation as my first equation. This is the first equation, this is the second equation. Then you can write from 1 subject t. Subject t. How to do this question today? So what you can do is, you can get x equals to t over t plus 1. Yeah, what you can get here is that first you cross multiply with it. X times of t plus 1 equals to t, then you can write xt plus x equals to t, then bring all the t terms to one side. X equals to t minus xt. So you can take t out. If you take t out, 1 minus x equals to x. Therefore, t become x over 1 minus x. That's the first part of it. Then what you need to do is substitute in the second equation, right? Okay. The second equation is 2t over t minus 1. Y equals to 2t over t minus 1. So y equals to 2 times of tt is x over 1 minus x over, this one you can say 1 minus x over 1 minus x. Then what you can get here is, you can expand these brackets. 2x over 1 minus x, from the denominator you can take this LCM. 1 minus x over 1 minus x. Then this is turn up to y equals to 2x over 1 minus x divided by 1 minus 2x over 1 minus x. That is 2x over 1 minus x into 1 minus x over 1 minus 2x. So you can cancel 1 minus x to 1 minus x. Let's turn up to 2x over 1 minus 2x is the final answer for this question. Right. Okay, so that kind of questions only, initially they can ask from this section, but we'll go ahead with another example. They might give you this kind of thing. They might give you x equals to square root of t plus 1, and they might give you y equals to t squared plus 1. So they might give you t is greater than or equals to minus 1. These are boundary conditions anyway. So they ask us to find the Cartesian equation. The Cartesian equation, right? Okay. Sometimes they specifically mention in form of y equals to fx. Or anyway, usually when you are writing the Cartesian equation, we used to write the subjected fact with y. So that is a usual condition where we mark. So you can get, you will get x equals to square root of x plus 1 is my first equation, and y equals to t squared plus 1 is my second equation. Then you can write from first equation, you can get subject x. Subject x, that is x equals to, sorry, this is for the t plus 1. Just made a mistake. T plus 1, if you square the both sides, x squared equals to t plus 1. Therefore, t equals to x squared minus 1 is my first equation. Then you can write substitute in second one. So you can write y equals to t is x squared minus 1 squared plus 1. It's turn up to y equals to x squared minus 1 plus 1. Y equals to x squared is the one which is explained by this Cartesian equation. That's a way of getting the answer for this question. So sometimes they might ask you the domain and the range. The domain and the range. If you ask about the domain for this question, domain and range. If you refer to domain, you know that this graph is t value is more than minus 1. T value is more than minus 1. Therefore, what you can understand is, but if I put minus 1, it's 0. Square root of 0 is, so if you just domain, if I get it, you know that x is equals to square root of t plus 1. We know that if I put t equals to minus 1, what would be the answer for this? X equals to square root of 0, that is 0. So after that, whatever the value you put it, it's more than 0, obviously, because we get the positive part of it. Therefore, you can say domain would be x is greater than or equals to 0. The range. Now you can see this graph is t squared plus 1. T squared plus 1, y equals to t squared plus 1. Here also we know that t is greater than 0. If I put 0 here, what do you get with it? Sorry, t equals to minus 1 here. Minus 1 here, minus 1 squared is 2. Sorry, 1 plus 1 is 2. Y equals to 2. So after that, if I put 2, minus 1, 0. If I put 0, t equals to 0, then what you get with it? You get the answer y equals to 1. Again, if I put 1, it's y equals to 2. So like that, it's forming a quadratic equation which is having the minimum value for plus 1. Therefore, you can say range is y is greater than or equals to 1. That is the answer where we need to write with the range. Sometimes they refer with they expect you to find the domain and the range. That's a way of getting the answer for this question. Right. Okay. Right. Let's go with another example. It's just like this. They might give you x equals to, on the example. I think this is example 4. Yeah. X equals to, they might give you t squared plus t, then 2t minus 2, and y equals to square root of t plus 1. So what you need to get here is, from 1 and 2, first of all, they would refer with the find the value for, what do you mean by this, the Cartesian equation. Find the Cartesian equation based on that. Part A, Cartesian equation. Part B, range and domain. Range and domain, that's all. So initially, we'll try to form the Cartesian equation. So you can say from 1, you can say x equals to t squared plus 2t minus 2. To subject t, what you need to do is put a quadratic. From a quadratic equation, if you want to subject one variable, you have to use the completing squares for this. So you can write this is t plus 1 whole thing squared minus 1 squared minus 2. So x is equals to t plus 1 squared minus 3. Then substitute in the part, substitute in 2. So you can say y equals to square root of t plus 1 squared minus 3 plus 1. So it's turned up to y equals to square root of t plus 1 squared minus 2 is the answer for this problem. Then they can ask you the range, part B. Sorry, initially try to find the domain. Domain we can find by the x value. You know that t, there is no restriction for t, obviously. So over here, you can see it's a quadratic graph. It's a quadratic graph. From here, you can see if you draw this variation of this x with t, it is the minimum. It's a graph with a minimum, like this graph. It shows a minimum value of where minus 3 when x equals to t equals to minus 1. So this is the minimum value for that. For the x, we can go ahead to the minimum value for minus 3. So therefore, you can say domain x is greater than or equals to minus 3. Then if you refer with the range, range. How to find the range? Range comes with this equation. Y, sorry, y. Right, okay. Then what you can understand is for the range, it's a square root of it. If I draw the root t plus 1 graph, it's a graph like this. So over here, why can we go ahead with this side, and this also can to go ahead with this side? That is a way of getting this, because you know that there is no restriction for this. If you just draw this graph t squared, if there is no restriction given here, so you can work out, you can write range is y is any real number. There is no restriction. But in any case, if they mention somewhere like this, if they mention y equals to plus root t plus 1, in that case, when you sketch this graph, you can't draw the negative part of the graph. They are referring to only the positive root. In that case, its range become y is greater than or equals to 0, not more than that, because from over here, they have not specify any factor over here. Therefore, it can go ahead with the positive to negative infinity. That is why I wrote the range like this. But if it is a situation like this, it's only the positive part of it. For you should be able to understand how to work out that kind of questions with it, right?